Again, thank you to everyone who's here to join the MS in Data Science info session at Willamette University. We're excited to share more information about this innovative program kicking off its fifth recruiting year. First off, I'd really love to introduce you to Jameson Watts. He's the Dean of the School of Computing and Information Sciences at Willamette. He's also the originator of the MS in Data Science program and knows it better than anyone on earth. So we're lucky to have Jameson here with us. I'll let you take it away.
Thank you, Hillary. Yeah, I've been around maybe a little too long. I have taught almost every single class in this program. So yes, I know it intimately. So like Hillary said, I'm the Dean of the School of Computing and Information Sciences. What that basically means is that I'm in charge of all of our computing and data science content at the university, both undergraduate and graduate. At the graduate level, the Master's in Data Science is one of two master's programs that we have on offer. And it is the program that has been around the longest. So let's get started. All right, first off, what the heck is actually a data scientist? This is actually more confusing than many people give it credit for. The term data scientist is thrown around in industry all the time without folks really having a good understanding of what is meant by the term. What you see on the screen is one definition, and it's a definition that I like for the most part, and it talks about some of the main components of this profession. You got to know a little bit of programming. You need to be able to manage data. There's definitely a bit of statistics in there, and then of course deriving insights. And so if you take this definition and you map it to, kind of this world of activities that exist out there, data science largely exists kind of at this intersection of programming and statistics in most people's minds, where on the one hand, you need the programming skills in order to automate, all of the things that a computer is and can do. And then you need the statistics in order to be able to take all of that data and actually make sense of it. What a lot of definitions miss is the importance of context in this whole definition. And context really means domain expertise. So you can know as much as you want about programming and or statistics, and you can still be terrible at data science if you don't understand deeply the context within which you are operating. And so you could think about context, like maybe you're working for Nike and you're trying to sell shoes, or maybe you're working for the state of Oregon and you're trying to optimally place kids in foster care. Or maybe you're working for the Department of Transportation and you're trying to reduce, freeway fatalities, right? So these are all contexts where your ability to program and model depend on your deep understanding of what's actually going on behind the scenes. And so if you think about data science, it's broader than just programming and statistics. You also need to know the context, because managing data requires a deep understanding of the context within that you're operating within, and being able to derive insights also depends on you understanding the context that you're operating in. And of course, if you're going to actually change minds, you have to learn how to take all of this stuff and be able to present it to the decision makers within an organization. Why data science? So it's a pretty cool job. Actually the #1 most promising job according to LinkedIn. And if you look at the Bureau of Labor Statistics, which just came out with their kind of forecasts for the next 10 years of job growth. All of the jobs that aren't in healthcare are focused on either data science, statistics, or software engineering of one form or another. And so even though the economy looks kind of weird right now, if you're trying to, career proof the next decade of your life, this is a great direction to go in. It's topped Glassdoor's list of best jobs for the past 3 years. Median salary of 130. Now, this isn't your starting salary, depending on how much experience you have, although we have placed folks at much higher than that. They came in with a lot of experience. 50% of the jobs in the top income quartile actually require some degree of coding skills. And if you just look at the data, even taking one course in computing or data science tends to double your job prospects and increase starting salary by between 15 to 20,000. And then this is a crazy statistic. Everyone talks about the importance of STEM education, but if you look at the number of job openings that exist out there, the number of openings in computing and data science are greater than all of the filled positions in every other STEM field combined, right? So take every single job that exists out there in every single STEM field, add them up. There are more open, unfilled positions in computing and data science than there are filled positions in all of those other fields combined. So the demand is still pretty high. Well, how the heck do you actually data science? If you look at LinkedIn and you start typing data science into their job search, these are the skills that show up most frequently. So you got to learn some programming, typically in R and or Python. We deliver both. Data engineering, so this is kind of largely the data management side of the job. And then, of course, some modeling components. So everyone wants you to understand machine learning and AI these days. However, there's a hidden qualification, right, in all of these job postings, and that's communication. And I have a lot of connections in the Portland tech community. Every single person that I talk to tells me that communication is the number one differentiator for their technical employees. And so techies who can communicate and present ideas are going to get ahead in any of these fields. Here's another way of looking at the data science world. If you've heard of Maslow's hierarchy of needs, this is the data science hierarchy of needs. This is not my pyramid. This is one created by Shopify in a blog post. However, it's the same. You can search data science hierarchy of needs anywhere online, and you'll find very, very similar pyramids elsewhere. But the idea here is to talk about how you actually build to an insight. And so at the very pinnacle, right at the top of this pyramid, you've got AI and deep learning. Below that, you've got kind of more traditional machine learning methods, A/B testing, some experimentation. Below that, you've got kind of analytics and descriptive statistics. Below that, you've got to actually transform the data so that it is analyzable to begin with. Below that, there's data wrangling, so moving around, storing it, accessing it. And then at the very base of the pyramid, you have everything that contributes to the data aggregation and collection process, so data generation in general. And if you think about the job market in data science, the volume of jobs out there roughly tracks the size of each level of this pyramid. The vast majority of jobs that exist are in the data generation, data wrangling, data engineering portion of data science. And very, very few of the jobs sit up at the pinnacle or at the top of the pyramid in terms of actually doing things like generative AI, chatbots, all of the things that are hitting the news headlines these days. So think about that in terms of how you design your own careers as well, right? There are lots and lots of really, really interesting problems to solve at every single level of this pyramid. But as you think about what skills you want to focus on, just know that focusing on the skills with higher volume of jobs is going to help you in the job market, especially if you're early career versus later career. All right. So how is our program organized? We are responding basically to these market needs with a series of 9 core courses and 3 electives. Our required courses include Foundations of Data Science, where you're learning the basics of data wrangling and some scripting, data visualization and presentation, which is exactly what it sounds like. Fundamentals of data engineering, where you're learning things like how to write SQL code to access and manipulate data, and also things like enterprise data architecture, cloud computing, and kind of ETL strategies for transforming data into forms that can be analyzed further up the pyramid. Data ethics, policy, and human beings. We are the only program that I am aware of that requires an ethics course as part of the curriculum. And this is becoming increasingly important as additional regulations come down from our local, state, and federal governments. And as organizations become more aware of how algorithms actually kind of can enhance bias in the products that they deliver online. 5th, applied machine learning. You're going to learn the basic algorithms behind the vast majority of machine learning models out there. And then dive into a little bit of deep learning and maybe reinforcement learning, neural nets, that sort of thing. And then you have a capstone seminar where you get to pull all of this together and work on an actual data science project that you present to a panel of industry experts at the end of this process. In addition to these 6 core classes, you get to pick 3 electives. And not all of these electives are offered every single year, but many of them are. For instance, this year we've got some cloud computing, some Power BI, some cybersecurity, survival analysis, and marketing analytics. And we're working on a new elective in data consulting, which we're really excited about, and a few others that aren't even listed up here. Let's see. All right, next. This would be an example pathway through our curriculum. So starting in fall 2024, you would take 3 required courses. So it's kind of a fixed menu in your first semester in the program. You're going to take your foundations course, your ethics course, and your visualization course. During your second semester in the spring, you'll take data engineering and applied machine learning, and then you have 1 space for an elective. Here, I put communicating with data in as the spring elective. Over the summer, the only required course is your capstone course, and then you're allowed to take 2 additional electives beyond that. And so we are offering courses like advanced machine learning and data consulting in the future. And so I added those as example electives for purposes of illustration. We also have a robust career readiness program that runs in parallel with our 12-month program. In the fall, we have a big networking event. This year's event is on October 27th. Hillary can tell you all about it. It's going to be awesome. Last year's event was really awesome. At this event, we invite all of our industry friends of the program to come hang out with us. We typically have a keynote speaker, and then we invite all current and former MSDS students to come network, talk about how they're doing on the job market, and make connections so that you know who to call and who to talk to when you want to learn more about folks working at different places around town. We have a bunch of workshops to get you ready, and then we go over kind of a career checklist with you that the intention is that you kind of fulfill throughout the 12-month period. In the spring, you will have more individual advising. You'll do some kind of auditing of your LinkedIn profile, of your resume, et cetera. And our career consultant will be presenting on kind of the current state of the career landscape for these sorts of skills. Over the summer, we incorporate a lot of our career programming into the capstone class. So there are practice interviews. We're working on portfolio pieces and making sure that you have something to bring to your interviews. And then we bring in often several industry speakers that can give you some perspective and context about how data science work is actually done out in the wild. Recent placements, we've sent folks to KPMG, Activision, the San Diego Padres, Nordstrom, PitchBook, State of Oregon, Daimler, Liberty Mutual, Standard Insurance, Boeing, Sony, the list goes on. Majority of our graduates have jobs 3 months after graduation. However, that varies, and it varies depending on experience. And it varies depending also on how much work you put in during the 12 months that you're in the program as well. But most of our students do quite well when they exit the program. Details, 36 credits over 3 semesters. So you're taking 3 4-credit classes per semester over 3 semesters. However, many folks who enter our program are also working professionals, and that is a lot of graduate school to take on all at once. And so there are options to take 1 or 2 classes per semester and extend the period of the degree over a longer time frame as well. All classes are offered in the evenings in either Portland or Salem, depending on which cohort you join. Elective classes are typically assigned either a Portland or Salem location. And so if there's a particular elective that you're excited about, but it's only offered in Salem and you're in Portland, then you may need to drive down to take that. However, there's always an elective option available in the location where you're primarily located. And we are experimenting with a couple of electives offered in hybrid and online format as well. Scholarships and financial aid. If you happen to be affiliated with the great university called Willamette in some way, shape, or form, you get an automatic 20% discount on your tuition. Congrats, alumni. That's a great discount. But we also have merit-based scholarships. Everyone who applies to the program is evaluated for a merit scholarship. And Hillary can answer questions about kind of typical scholarship dollars at some point offline if you're interested in those numbers. Application, we require resume, transcript of your undergraduate college essay, and 2 letters of recommendation. We do not require a GRE or GMAT, but we do like to see at least a little bit of programming and statistics experience in your background. If that's not something you have, or it's not something you've recently engaged in, we do recommend several free online classes. There's a couple of like edX classes from Harvard and elsewhere that you can take for free that get you ready and prepared during the summer prior to the program's start. And I think Hillary already mentioned this, but our early action deadline is December 15th. So get on it if you want to be considered for those merit scholarships. And I think that's it for me, Hillary. I am happy to answer questions if they exist.
Excellent, thank you. And yeah, some questions have come in through the chat. Let's answer those. And I'm here too. One thing to know is that I'm your representative kind of throughout the application and admission and enrollment process. So if you have any questions about the application itself, this is a great time to ask as well. I'm also working closely with Jameson and other members of the faculty to do our interviews, that kind of thing, if you have any questions about that process. So let me see. Ryan, you recently asked a question in the chat. Do you want to ask to the group? Okay, so Ryan still has his mute on. He was asking about whether this is the same program as the 3+1, which it is. That's one of the great things about the MS in Data Science is it's also available to students on the Salem campus in an accelerated degree where they can join the same cohort as seniors. Is there anything you want to add to that, Jameson?
Don't think so.
Okay, great. And David, I remember seeing a question from you in the chat too. Do you want to go ahead and ask?
Yeah, it's kind of related to the hierarchy that Jameson was showing there. And it just a curiosity, as you kind of specialize going up that stack, do the salaries sort of increase the same way with that, as you become more oriented towards AI and this and that? Just a curiosity. It's just curious how, if that's the case.
I actually, I don't think so. So what you'll find actually is that data engineering jobs are pretty well compensated.
Mm-hmm.
And
they come in different levels too. There are some very
right.
advanced senior data engineering jobs. Sorry, go ahead.
So if you think about you've got data engineering at the bottom, you've got kind of your like PhD statisticians at the top of that pyramid, and then you've got your analysts and kind of ML engineers in the middle somewhere. There can certain analyst positions, can be lower paid than the data engineering or machine learning engineer positions that exist out there. But even that isn't guaranteed. It kind of depends on what you're doing. So a lot of analyst positions are client-facing consulting roles, right? And those can be very well compensated. There are pathways to career growth regardless of where you decide to focus within the pyramid. And I often tell people, you should pick between kind of three basic types of data scientists. One is the more kind of what I would consider the programming heavy data scientist. And so this person is often more on the data engineering side. They deal with machine learning operations, they deal with deployment, they deal with moving massive amounts of data around databases, they deal with enterprise architecture, that sort of thing. Then you've got the modeling data scientist, and these tend to be more statistics focused individuals. So folks who are, heavy into kind of the underlying algorithms that are driving the machine learning outcomes. They're interested in, causal modeling, econometrics, and kind of deriving statistical insights from big data. And then you've got the third path is really kind of a data consulting path, which involves a lot more descriptive statistics, some predictive analysis, but a lot of communication, a lot of presentation, and a lot of kind of delivering insights in a way that clients can understand and interpret.
Great. Sorry, you see me like, sorry, I didn't have my mute on. I'm like typing furiously in the chat. There's lots of questions coming in from there too. So Chloe asked about integration with the MBA program and the joint degree. Do you want to comment on how curriculum looks for our joint degree students?
Sure. So for the joint degrees, and for those of you that don't know about this, we have a joint degree with the MBA program. It's a longer push, so it's 2.5 years rather than 12 months. And you enter the program as an MBA student, and you take core MBA classes during your first semester. You also take core MBA classes during your second semester with the addition of the data engineering class. We then recommend that you do an internship over the summer. And then in your second year, you'll take a few more of the core data science classes throughout your fall and spring semester, along with electives from the business school. And then during the summer following your second year, you will take 3 data science classes and 1 MBA class. And so that final semester is a full college semester, full-time, heavy lift, hard work. But the students who go through the joint program, they love it. And they often do really, really well on the kind of data consulting job market, right? Where you've got, a deep understanding of some business context, but you also have the tech skills to be able to explain the insights that you're delivering.
Great. So we can open up to the group. Are there any other questions?
Looks like there's a few at the bottom of the chat, Hillary. Do you want to pick one or two?
Sure. Let me see. So Parker asks whether this program would benefit you as an actuary. And I said yes, there's a lot of crossover with actuarial science, right? But I also wonder if you would stay an actuary after you leveled up.
I wonder if you would. I had I actually had a student at one point who was an actuary who wanted to leave actuarial science in order to pursue other things, and was looking at us as an escape hatch. And nothing against actuarial science. I think it's actually quite useful. What I would think is that the combination of actuarial science with data science is quite a powerful combination for pursuits like fraud detection in bank applications, right? Would be, one kind of obvious route, because of course the error rates or the risk, right, in that process is what gets fed into an actuarial table that defines the rates that people pay. Right. So there's a lot of, kind of intermixing there in terms of the content.
Nice. Thank you. David, do you want to ask your question?
Yeah, it's a bit of a long one, but I'm really curious. And Hillary, you and I spoke to this yesterday, just a little bit before the Data Vision Society. But I've been working in the innovation space for years, and I'm looking to potentially see if weather can be predicted my background is in environmental science, and so I want to combine many different things. But can weather be predicted as well through machine learning versus the current supercomputer number crunching? I'm curious because I see a lot of questions around MBA, business, and this and that, but I'm looking to sort of apply a lot of this stuff to some new areas, which is the innovation in climate. So I don't know if you can speak to any of this, but would love some of your thoughts.
Yeah, so weather modeling, so let me preface this by saying that I'm not a climate scientist, and so take everything I say with a grain of salt. But I do have at least a kind of a basic understanding of how these models work, and weather models are a combination actually of machine learning and theoretical models, and so kind of some adding some physics, right, so that constrain how things actually occur, in terms of expanding gas with heat and contracting with cold and those sorts of things. But then you add in a bit of kind of traditional machine learning on top of that to fine tune some of the physics predictions. So it's already going on, is what I would say. And so yes, I think machine learning does improve this sort of model. I also think that there are kind of more applications than I can gracefully enumerate in this forum for machine learning in environmental science. And I can think of a few right off the top of my head. One, I have a friend who does models for salmon migration in the Columbia River. And so looking at kind of GPS tracking of the primary salmon predators as a way of actually predicting salmon runs. There are others like categorizing, using satellite imagery to categorize fire risk in Southern Oregon, right, is another application of machine learning methods to kind of an environmental science or policy problem. Also related back to actuarial science, because if you're going to get home insurance and your house is in a forest, the rates on that insurance are going to derive from what the client scientist models. So I think the methods that we teach are just the beginning, right? And the application of those methods are what excites me, honestly, because my students go in all kinds of different directions at the end of this program.
Yep. Great. Thank you.
Great, thank you. Yeah. Mm-hmm.
So Anya had a question about the interview process in the application, whether we require interviews. We do. So if you make it through kind of initial screening levels and we're considering you for enrollment, we'll invite you to an interview, which will be about half an hour on Zoom. It's usually with me and a member of our faculty, so that you have the opportunity to ask some questions about the program. And it becomes informational on both sides. So something good to know. And then Ryan has a question. Ryan, do you want to ask? Okay, Ryan, I will ask for you. So he asks, if I were to study abroad for data science, what would be the best options in your opinion? What countries are leading in data science?
Countries are leading. I don't really know, honestly, but I've got some friends in France that are doing it, so maybe go there. Yeah. That sounds like a nice place to study data science.
Yeah,
like preferably like on the beach in the south of France.
Well, I mean, that makes me think right away about how well-rounded successful data scientists are. Like it's a good opportunity to go and learn about a topic that ties in somewhat, even if you're not necessarily doing like machine learning models in another country.
Absolutely. And my retirement plans are to develop a surf forecasting model, in my spare time.
Perfect. Have we addressed all the questions in the chat? Are we waiting on anybody? Oh, David's a surfer too. David's going to help you. I think, yeah, his capstone.
Yeah, 100%.
Excellent. Well, Seaside looks pretty good tomorrow morning.
Nice. All right. So if there are no other questions from the group, I think we're okay to wrap it up. I'll throw in a couple things at the end, and Jameson, please to cut in if there's anything else that you want to add. As we mentioned, our first round is December 15th. We're going to continue to review applications and admit all the way through probably the end of May for an enrollment next fall. We have only one enrollment time during the year, which is the fall. As Jameson mentioned, most of our students join in the fall and graduate in the summer, but we have the option to split into additional years if necessary. There's not a separate application for part-time versus full-time. So you're welcome to make that change kind of midway through the program with no problem at all. I'll also throw in, as Jameson mentioned, next year we're introducing an MS in computer science, which we're really excited about. A week from tonight, we're doing our first info session in the MSCS. So if you'd like to come and join for that, you're perfectly welcome to do so, or help us spread the word about this new program that we're really excited about. Great. Anything
Thanks, Hillary.
Yeah, thank you. All right, thanks everyone for joining. Please feel free to reach out if you have any questions at all.